we can use composition to determine if two functions are inverses of each other. When we find an inverse, we switch x and y and solve for y. Really, inverses are reflections about the line y is equal to x. That's why we're able to swap x and y. That means that if we take g and we put it inside of f and simplify, our answer should equal x if they are indeed inverses of each other, and vice versa. If we put f inside of g and simplify, it will equal x if they are inverses of each other. Just remember that you need to identify what the domain restriction is on the inside function. So let's go ahead and determine if these two functions in the question below are inverses of each other. I'm going to first find the domain restrictions. So the domain restriction for f of x, we can't have our denominator equal to 0, so we're going to set the denominator equal to 0 and solve. So x cannot equal 4. For g of x, x cannot equal 0. If we plug in a 0 underneath the 6, then the whole thing is undefined. These are our two domains. We need to keep that in mind when we're identifying composition. So it says show that f of x is equal to 6 over x minus 4 and g of x, which is equal to 6 over x and then plus 4, are inverses. So I'm going to start by putting g inside of f. So the first thing I'm going to do is I'm going to replace g of x with the expression for g of x. Then I'm going to put my expression in f of x. So notice that the only thing I did was I replaced the x in the original f function. Now I'm going to simplify. Positive 4 and negative 4 equals 0. So then I'm left with 6 over 6 divided by x. I'm going to write this horizontally. Then I'm going to change the division to a multiplication. I'm going to make that a dot, just so we don't get confused with the x's. So we're going to multiply by the reciprocal. The 6's cancel, and we're left with x. Don't forget that we still have that domain restriction on the inside function. So x cannot equal 0, or in interval notation, so we've used composition to show that f and g are inverses of each other, because when we put g inside of f, it's simplified to be x. Now let's prove it the opposite way. Let's put f inside of g. So the first thing I'm going to do is I'm going to replace f of x with the expression for f of x. Then I'm going to put it inside the g function. So I'm going to take this and I'm going to put it in for x. So 6 over so as you can see, the x in the g function has been replaced with the f function. Everything else stays the same in the g function. And then I need to simplify. I'm going to simplify the left-hand term first. So when we put f inside of g, we end up simplifying to have x. Don't forget the domain restriction for the inside function. The inside function is f of x. So if we look at our original domain, x cannot equal 4, and how we write that in interval notation. The other thing you're going to be asked to do is to actually graph your inverses. We've spent a lot of time learning how to graph functions. We're going to use those same tools to actually graph inverses. So we'll make a table of our original function. Then, because an inverse is switching our x's and y's, we're simply going to switch our x's and y's in the table of values. And then we're going to graph our new table of values.